Hi, this is Mrs. LaBarbara. This is AP Physics Chapter 8, Momentum, Impulse, and Collisions, Video 5. Today's topic is center of mass. The objectives are to understand the body of collection of particles can be treated as a point particle located at center of mass. Be able to apply center of mass equation to solve problems. Let's see center of mass. Suppose we have several particles with mass m1, m2, and so on, such as the one shown in the picture. That coordinate of m1 be x1, y1, and m2 be x2, y2, and so on. So we can determine the center of the mass of the system as a point that has coordinate as x center and y center given by this equation. So this equation is the center of the mass, is mass-weighted position of the particle. So m1, x1 plus m2, x2, and so forth, divided by the total mass. So now consider homogeneous objects. Their center of mass is at their geometric center. So for this object, like a donut, a ring, or a disk, the center of the mass is along the axis of symmetry. And as in the case of the donut, the center of the mass not necessarily be within the object. Let's take a look at this example. So this figure shows the simple model of the structure of a water molecule. The separation between the atom is d equals to 9.57 times 10 to negative 11 meters. So here is the oxygen, here is the hydrogen. That's the distance between the two. So each hydrogen atom has 1 U and the oxygen atom has 16 U. Find the position of the center of the mass. So write down what's given. The oxygen is 16 U. Let's use the position of oxygen as your origin. X1 equals to 0 and Y1 equals to 0. M2 is one of the hydrogen above the 0 axis. X2 is d times cosine theta. See, I cut 105 into half. That's why I got 52.5 degrees. And Y2 is the sine. Similarly, M3, particle 3, is the hydrogen atom below the x-axis. So its Y2 is negative. After you plug everything into the equation, this is what the result. X center of the mass is 6.5 times 10 to the negative 12, and Y center of mass is 0. What does this tell us? The center of the mass is much closer to the oxygen atom than either hydrogen because the oxygen atom is much more massive. Notice that center of the mass lies along the x-axis. This is because the x-axis is symmetry of this molecule. Let's do another example. Now you have 2 bars plus a ball, right? One bar is 4 kilograms, the other bar is 3 kilograms, and here is a ball. How do you find the center of mass in this case? Well, you can treat each bar as a particle. The particle is located at the center of the bar with the same mass. So now you have 3 particles. It's easy to find the center of the mass with 3 particles. Particle 1 is 4 kilograms. Its location is negative 0.75 because it's in the center of the bar. And here is why. I choose this 0, 0 at the hinge because I find that is most convenient for me. You can choose 0, 0 at any point of your choice. Plug that equation, we can find the center of the mass is negative 0.33 and Y center of mass is negative 0.70. It's negative 0.33 is more closer to this vertical bar because the vertical has more mass. And again, the Y should be lower than the 4 kilograms because most mass is below this 0. Let's take a look at motion of center of the mass. From the center of the mass coordinate, we know velocity is dx over dt. So from there, we can find the center of the mass. Velocity of center of mass is just the average velocity over the total mass. So this is mi times vi is total momentum. You add it together. So basically this one is saying the total momentum of the system is the total mass of the system times the velocity of the center of the mass. So that's the same as all the momentum added together. So basically, you can treat the whole system with all different masses as one particle. Where is the particle located? At the center of the mass. We can use that velocity to find total momentum. We can use that acceleration to find the net force. So total momentum is equal to the total mass times the velocity of the center of the mass. Let's take a look. This is a picture of a wrench, like a rotating. And you can, although it seems to be complicated because the wrench is rotating, but we can treat this wrench as a point mass. If you look at the center of the mass, that is moving at almost a constant speed. It's have a little bit acceleration moving in a straight line. So the center of the mass of this wrench is marked with white dot. The net force is really almost zero. It does have a little bit acceleration. So as the wrench spins on a smooth horizontal surface, the center of mass moves in a straight line with nearly a constant velocity. So it's probably moving upward. There is a little bit of friction, so you can see the velocity is decreasing slightly. But you can treat the wrench as a point particle. Where is the particle located at the center of the mass? Okay, let's take a look at another example. James and Raymond are standing 20 meters apart on a slippery surface of a frozen pond. Raymond has a mass 60 kilograms and James has a mass 90 kilograms. Midway between the two men, a mug of their favorite beverage sits on the ice. So they pull on the ends of a light rope that is stretched between them. When James has moved 6 meters toward the mug, how far and in what direction has Raymond moved? So here is the situation of James and Raymond. Here is the mug right in the middle. So because there is no external force, net force equals 0, center mass has to remain constant, so that the mug be 0 point. So center mass is the same before they are started pulling, and when they are pulling, they are the same. So here is M1, X, your start, James at a -10, after is -4. How did I get -4? Because James moved 6 meters toward the mug. So the new position is -4 from the mug. And we want to find Raymond's position. Plug this in. We find Raymond's position is 1 meters from the mug right over here. That means Raymond must move the 9 meters because originally it was 10. Now his position is 1, so Raymond has moved 9 meters toward the mug. So ratio of how far each man moves. How far each man moved? James moved 6, Raymond moved 9. That equals to the inverse ratio of their mass, 60 over 90. This result is completely independent of how hard either person pulls. The pulling harder just helps Raymond to get to the mug sooner. Okay, this is because of conservation momentum. The distance is the inverse ratio of the mass. Let's take a look at another example. So 40-kilogram woman stands on a 60-kilogram canoe 5 meters long. She walks from a point 1 meters from one end. So over here is 1 meter to a point to the other end from 1 meter, right? To over here. If you ignore the resistance of the canoe in water, how far does the canoe move during this process? So let's take a look. There are 3 points of interest: the women's position, the center of the boat position, and the center of the mass of the woman and boat system. So that's the center of the mass, that's the center of the boat, and woman. So from here, we know the woman is 1 meters from the end. So since the boat is 5 meters long, so from the end of the boat to the center of the boat is 2.5 meters. That means here is center of the mass. That distance be d. So the distance from the woman to the center of the mass would be 1.5 minus d. So let's use the center of the mass. Position is 0, 0. Why is that? Because when a woman moves, the center of the mass is not moving, but the boat is going to move to the other side. And here is the middle of the boat. So the middle of the boat was here, D. The middle of the boat is going to be here. So how far did the boat move? We want to find out. So let's take a look. So if this is d, because it's symmetrical nature, so this has to be the d. Since this one was d, so the total distance has to be 2d. So this was the point before. From here to here is d, so the total has to be 2d. So in order to find how far the boat has moved, we have to find a d. To find this d, we can use center of the mass. Let center of the mass be 0, 0. M1 is 40, 45. X1 is the distance between the woman and center of the mass is negative 1.5 minus d, negative because it's to the left. And the boat is 60 kilograms. The boat position is d from the center of the mass. And because center of the mass, we have that as 0. So m1 x1 plus m2 x2 has to be 0. x1 is negative 1.5 times minus d. x2 is d. You can solve this. You will have d equals 0.6429. Now the boat has moved a distance of 2d, so it's 1.29 meters to the left. Now let's take a look at as external force and center of the mass. So we know V center of the mass is the average, the weighted average, or mass weighted average, is P divided by total M. A is dV over dt, so A center of the mass is the average acceleration, is mass weighted average acceleration. And mass times acceleration, that's a net force. So that is the net force, all the external net force divided by the total mass. So that means when the external force acting on the wrench is 0, A center of the mass is 0. The center of mass moves in a straight line with constant velocity or at rest. Total momentum is conserved. dP over dt, P total, that equals 0. But when the net force is not 0, the net force is the total mass times the center, the acceleration of the center of the mass. So even though you may have a lot of particles in the system, but if you know the acceleration of the center of the mass, you can figure out external force. So that equals dP over dt. Okay, let's take a look at the motion of the center of the mass. So in this case, you'll have a net force, which is gravity. So shell explode into two parts. Even though it explodes, the net force is still the same. So the center of the mass is still moving in a along the projectile. So after shell explodes, the two fragments follows individual trajectories. But the center of the mass continues to follow shell's original trajectory. This will keep on going as long as the net force on the system is gravity. So it will just keep going until the net force change. Let's take a look at check your understanding. Will the center of the mass in the figure continue on the same parabolic trajectory even after one of the fragments hits the ground? Why or why not? So suppose this one hits the ground. What happens? Is this still a parabolic trajectory? The answer is no. Why is that? Because if gravity is the only force acting on the system, then the center of the mass will follow the parabolic trajectory. But once the fragment lands, the net force is not gravity anymore because you will have a no more force acting on the system. So the net force is not a total gravity anymore. Therefore, the path is not going to follow the parabolic trajectory. That's it for today. Thanks for watching. See you next time.